Hello, geometry students. I hope everybody is doing well. We are in the next section of chapter 8. We are in section 8-2, and we're talking all about special right triangles. So what are special right triangles? Well, there's two different types. One is called a 45-45-90 triangle, and the other is called a 30-60-90 triangle. But what makes them special? Well, special right triangles have a consistent ratio between sides regardless of size. So we're always going to have this same ratio over and over and over again. And the first type of triangle we have is something called a 45-45-90 triangle. So what is that? What are we talking about when we say 45-45-90 triangle? Well, we're talking about the angles inside of that triangle. Notice how this angle is 45 degrees. This angle is 45 degrees, and this angle is 90. So if we have a triangle that has two 45-degree angles and one 90-degree angle, then it's going to be able to follow this special pattern. But what is this pattern? Well, essentially, it says that both of the legs of a 45-45-90 triangle are congruent, and the hypotenuse is that times the square root of 2. So if it were to all be reduced, this is what our sides are going to be. We're going to have 1, 1, and square root 2. Essentially, that's what we've got every single time with every single 45-45-90 triangle. So if this is what every 45-45-90 triangle can be reduced to, then I can say this triangle is similar to all other 45-45-90 triangles. So this is similar to all other 45-45-90 triangles. Now, hopefully you're remembering from chapter 7, if something is similar to something else, then we can set up a proportion, cross multiply. So that's how we're going to solve these. To solve, set up a proportion and cross multiply. So let's do that, shall we? We have an example 1. It says find the value of x, give your answer in simplest radical form. So we want to make sure we're paying attention to that. We have a 45-45-90 triangle. I'm going to draw another one right beside it with our measurements on it so you can see the similarity. So let's say we have this 45-45-90 triangle. And remember, we got 1, 1, square root 2. So I'm going to line up everything that I know that is in correspondence. So I know that this side 8 is corresponding with this side 1. And then I know this side x is corresponding with this side square root 2. So remember, with proportions, just keep it consistent. I'm going to say purple over yellow equals purple over yellow. So 8 over x is equal to 1 over square root 2. And let me write that in this other pen. Okay, now I have my proportion, just cross multiply and solve. So x times 1 is x, and 8 times the square root of 2 is just 8 square root 2. Remember, I kept the outside number with the outside number, and then the radical stayed the same. This is, in fact, in simplest radical form, so that's my answer. We're going to do that again. So we are looking for the value of x. This is a 45-45-90. If you need to put in your 45s, you can. I'm going to draw another triangle in the same position just so you can see it. So we have 1, 1, square root 2. I'm going to line up what I know matches. So this 5 corresponds with this square root 2. while the x corresponds with the 1. And if we find one of the x values, then we find the other x value as well. So we really just need one proportion for this. So I'm going to once again go, I'll go purple over yellow. So purple over yellow equals purple over yellow. So I'm going to have 5 over x is equal to square root 2 over 1. We want to cross multiply. So x times the square root of 2 is x square root 2, and 5 times 1 is 5. Okay, now I want to isolate the variable, so I'm just going to divide by the square root of 2. So now I have x is equal to 5 over the square root of 2. But remember, there's this little thing that we do not like, and that is when a square root is in the bottom of a fraction. So I'm going to rationalize this by multiplying it by a funky form of 1. The way I'm going to do that is by multiplying by the square root 2 over the square root of 2. So I'm following my rules of multiplication. Keep the outside with the outside and the inside with the inside. So the top of the fraction becomes 5 square root 2. And the bottom becomes the square root of 4, because 2 times 2 is 4, and they're both inside the radical symbol. But we know that the square root of 4 is actually 2, so for my final answer, I'm going to say 5 square root 2 over regular 2. I can't reduce that 5 and 2 because it's not going to give me a pretty number, so I'm just going to leave it in fraction form. All right, we have one more example on the front of this page, and it says a house designer wants the roof of a house to have a 90-degree peak. They also want the sides of the roof to be the same length. If the width of the house is 50 feet, how long do the ceiling trusses need to be? Okay, so we've got ourselves a house. Let's just start kind of organizing our work. I know that it is 50 feet across. And they're going to put in a roof, and they're saying they want the peak of the roof to be kind of like this image right here. So I'm going to do my best to kind of draw that on there. I know it's not perfect, but yeah, we're sticking with it. So we know that this whole length across there is 50 feet. We want to know this guy. How long is that guy? So we can draw a similar triangle once again, just to that, so we can set up our ratio. We're going to say 1, 1, square root 2. And when we do that, we're going to be able to line everything up. So I'm going to say 1 over x is equal to square root 2 over 50. Or you can say 1 over square root 2 is equal to x over 50. Remember, with the proportion, there's lots of different ways to solve it, just as long as you keep your proportion consistent. So my proportion is going to be 1 over x is equal to square root 2 over 50. Now I want to cross multiply, so I have x times the square root of 2 is equal to 50. And this is very, very similar to this problem up here. I want to isolate the x, so I divide by the square root 2. When I do that, I get x is equal to 50 over the square root of 2. But I don't like that. I don't want it to have a radical in the bottom of the fraction. So I rationalize it by multiplying by the square root 2 over square root 2. This is 1. This is like 5 over 5 or 9 over 9. Square root 2 over square root 2 is just 1. And if I multiply something by 1, I'm not changing the value of it. So this becomes 50 times the square root of 2 over the square root of 4, which is actually 50 square root 2 over 2, because the square root of 4 is 2. And 50 over 2 can reduce, so this becomes 25 square root 2. And there is our answer. If we wanted to round this, then we could just put that straight into our calculator. Let's see what we get. If we take 25 times the square root of 2, I am getting, just a moment. I am getting 35.4. So it's about 35.4 if I were to put this into my calculator. And that would probably be the measurement they would use in a construction site because they don't really have a marker that says square root 2 on a tape measure. Okay. So that was the 45, 45, 90 triangle. So just to remind you, it's called 45, 45, 90 because of the angles here. We have another one called a 30, 60, 90 triangle. The 30, 60, 90 triangle theorem is working very, very similarly, but now the ratio of the sides is just a little bit different, just a hair. So here are the relationships of the sides for you. The shortest side is 1. The longest side is 2, and the medium length side is the square root of 3. Now the 1, notice how up here is the 30-degree angle? Well, that's the smallest angle. So opposite the smallest angle is always going to be the smallest side. And 2 is a bigger number than the square root of 3, so we know that 2 has to always be the hypotenuse. But I'm going to write that down one more for you guys just so you can write it down too. The 1 is always opposite the 30-degree angle. And the square root 3 is always opposite the 60-degree angle. So notice here's the 60-degree angle. The side opposite from that is square root 3. Up here is the 30-degree angle. The side opposite from that is the 1. Now, I'm going to remind you just one more time. When you are setting up a proportion, your fractions must match. So, when using a proportion, match your fractions. That is huge. That's not going away, and that's very similar. That's very similar to what we were doing in chapter 7. Remember when I kept saying, just keep your proportion consistent and you'll be fine. That's going to be the same thing for these guys. So in example 3, we're using 30, 60, 90 triangles, and we're doing the same thing as before. So in the first one, it says find the values of x and y, give your answers in simplest radical form. Okay, I'm going to draw my similar triangle first. So I'm getting this drawn in. I'm going to say this guy down here is my 30 and this guy is my 60. And remember how we label the sides. So the side opposite from the 30 is 1. The side opposite the 60 is square root 3. And the hypotenuse is 2. Now I can use that to set up my proportions. I can say x over 1 is equal to 22 over 2, matching things up that way. Or I can say x over 22 is equal to 1 over 2. All of those work. So I'm going to say x over 22, so short leg over hypotenuse, is equal to 1 over 2. Short leg over hypotenuse. I lined it up. So the up and down with the up and down, and the slanty with the slanty. Cross multiply. So that gets me 2x is equal to 22. Divide by 2 on both sides, and I'm getting x is equal to 11. Cool. So I've got two sides of my right triangle known now. I know the x side is 11, and I know the hypotenuse is 22. To find the third side, you could technically use the Pythagorean theorem, but we don't want to do that in this situation just because I want to make sure that we are practicing the particular skill at hand. But of course, if there were not directions and you knew the Pythagorean theorem, then that would be a really good way to go for it. So once again, we have y, and then we have square root 3, and we have 22, and we got 2. So I'm going to say y over 22 is equal to square root 3 over 2. So y over 22 is equal to square root 3 over 2. Cross multiply. That is not in the screen. I apologize. So that's going to get me 2y is equal to 22 square root 3. I want to isolate this y. So how did I do this first real fast? So y times 2 is 2y. 22 times the square root of 3 is just 22 square root 3. Divide by 2 on both sides. And I'm going to get y is equal to, now remember, you divide the outside numbers with the outside numbers and the inside numbers with the inside numbers. So 22 divided by 2 is 11, and the square root 3 is along for the ride. Okay, so there is example A for part 3, or part A for example 3, I should say. Let's do the next one real fast. So once again, we're finding x and y. We're going to set up our ratio. So I'm going to draw this out just so you can see it. I've got my 30, 90, 60, and then I've got 1, square root 3, and 2. I'm going to line all of that stuff up to calculate my missing sides. So here I have x over 15 equals 1 over square root 3. So let's set that one up. So I have x over 15 is equal to 1 over square root 3. Top over left is equal to top over left. That's how I set up my proportion. Now I want to cross multiply. So 15 times 1 is just 15, and then square root 3 times x is just square root 3x. I want to isolate the x, so I divide by the square root of 3 on both sides. And now that's getting me x is equal to 15 over the square root of 3. Remember, we have a problem though. We do not want the square root of 3 in the bottom of the fraction, so I'm going to multiply by the square root of 3 on top and bottom. And that's going to get me 15 square root 3 over, now let's think about this so we don't write so many steps. The square root of 3 times the square root of 3 is going to become the square root of 9. But we know that the square root of 9 is actually 3, so I can just go ahead and go straight to 3 there. Now I can reduce this 15 and 3, so my final answer is going to be 5 square root 3 is what the value of x is. Let's do that for the y side now. So I'm going to say 15 over y is equal to square root 3 over 2. Or long side over hypotenuse is equal to long leg over hypotenuse. So my proportion is 15 over y is equal to square root 3 over 2. Cross multiply. So this is getting me the square root 3 times y is equal to 30. I want to isolate the y, so I divide by the square root of 3 on both sides. And that's getting me y is equal to 30 over the square root of 3. But we've got the same issue that we had going on up there. I need to rationalize the denominator, so I'm going to square root 3 on top and bottom, and that's getting me 30 square root 3 over 3. This reduces, and that's going to get me 10 square root 3 is equal to y for that final answer. All right, that's everything for these notes. We will be practicing with this quite a bit, so if you have questions, bring it to me in class, and have a good day.